Hello, in this video we're going to go over a solution to problem 3 from IMC 2022. By the end of this video you're going to learn how to use generating functions in solving problems. So the problem goes like this. Let P be a prime number if Li is starting at point 0 of the real line, and at each minute it moves 1 unit to the right, 1 unit to the left, or stays at the same point. And it wants to go back to the origin after P minus 1 minutes. F of P is the number of strategies to do this. For example, F of 3 would be 3 because it can stay there for 2 minutes, go to the right, go to the left, or go to the left, go to the right. These are the 3 possibilities for that. The question is asking us to find F of P mod P. I have a solution to this problem which I came up with, and I have posted a video on that, but after that I checked the official solution and then I saw a different approach, and I thought that would be a worthwhile approach to discuss so that you get a good understanding of how to use generating functions in solving problems like this. So the way we're going to approach this one is we're going to assign numbers to moving to the right, moving to the left, and staying at the same position. Moving to the right is denoted by +1, moving to the left is denoted by -1, and staying at the same position is denoted by 0. In order to get back to the original position, you need to have the same number of right and the same number of left. So for example, the reason that f of 3 is equal to 3 is that you can write down 0 as the sum of two zeros, or the sum of +1 and -1, and the sum of -1 and +1. So these are the 3 ways to represent 0 as the sum of two numbers, 0, 1, or -1. Another way of thinking about that would be to write down 1 as x to the power of 0 times x to the power of 0, x to the power of 1 times x to the power of -1, and x to the power of -1 times x to the power of 1. In other words, in order to find f of 3, we need to find the constant term of 1 plus x and x inverse to the power of 2. How does that work? The way it works is that if you multiply 2 copies of 1 plus x inverse, you're multiplying the terms, and in order to get the exponents to add up to 0, it means you're producing the constant coefficient. Now, in general, f of p would be the constant term of 1 plus x inverse to the power of p minus 1. So for the rest of the time, what we're going to do is we're going to simplify this expression and find the constant term in 1 plus x inverse to the power of p minus 1. However, since they're asking us to find the coefficient mod p, we can work on everything mod p. In other words, we're going to work inside zp, which is the field of integers mod p. Simplifying the expression that we found and taking the common denominator, we get 1 plus x squared to the power of p minus 1 divided by x to the power of p minus 1. We are looking for the constant term of this expression. If you multiply the numerator and denominator by 1 minus x, we get 1 minus x cubed over 1 minus x, and both of those are raised to the power of p minus 1. Now I'm going to separate that as 1 minus x cubed to the power of p divided by 1 minus x cubed, and the denominator can be split into 1 minus x to the power of p divided by 1 minus x. Now, since we are working in field of integers mod p, we can actually simplify the expression 1 minus x cubed to the power of p and also the expression 1 minus x to the power of p by a very simple fact from number theory. And that fact is that a plus b to the power of p is equal to a to the p plus b to the p when we are working mod p. And the reason is when you expand a plus b to the power of p, you get a bunch of terms with p choose k, and each of the p choose k's are 0 if k is positive and less than p. And the reason for that is relatively simple, because when you write down p choose k, you have a p factorial in the numerator which is divisible by p, and in the denominator you have k factorial, p minus k factorial, neither of which is divisible by p, which means the entire expression of p choose k is divisible by p. When you take it mod p, you get a plus b to the power of p is a to the p plus b to the p. Back to the original problem. 1 minus x cubed to the power of p is going to be 1 minus x to the power of 3p. 1 minus x, we're going to keep it untouched, and we're going to simplify 1 minus x to the power of p as 1 minus x to the power of p, and then multiply it by 1 minus x cubed. In order to find the constant coefficient of that, we could multiply by x to the power of p minus 1 and look at the coefficient of x to the power of p minus 1 in 1 minus x to the power of 3p times 1 minus x divided by 1 minus x to the power of p times 1 minus x cubed. So for the rest of the time, we're going to simplify this and we're going to find the coefficient of x to the power of p minus 1 in that expression. The numerator can be left, 1 minus x to the power of 3p times 1 minus x can be left alone. For the denominator, we're going to use the geometric sum. 1 over 1 minus x to the power of p is the sum of x to the power of pk. And 1 over 1 minus x cubed is the sum of x to the power of 3k. In order to get the coefficient of x to the power of p minus 1, I need to look at how I can create x to the power of p minus 1. We can only choose 1 from the first term, 1 minus x to the power of 3p, in order to get to x to the power of p minus 1. From the second term, we can choose 1 or x. From the third term, we can just choose 1, and from the last term, we're going to have to choose some x to the power of 3k. So it's clear at this point that we have to take cases when p minus 1 is a multiple of 3 and when p minus 1 is a multiple of 3 plus 1. If p minus 1 is 3k, from the first parentheses we'll have to choose 1, from the second parentheses we'll have to choose 1, from the third parentheses we have to choose 1, and from the last one we will have to choose 3k, which means f of p is congruent to 1 mod p. If p minus 1 is 3k plus 1, then from the first parentheses we will have to choose 1, from the second one we will have to choose negative x, from the third one we will have to choose 1, and from the last one we will have to choose x to the power of 3k, which means f of p is negative 1 mod p. And if we summarize all of that with the fact that for p equals 3, f of 3 is 3, which is 0 mod p, that's something that they gave us, we obtain that f of p mod p is 0 when p is 3, 1 when p is 1 mod 3, and minus 1 or p minus 1 when p is negative 1 mod 3. If you like this video, make sure to subscribe to the channel where you can find more videos like this. I'm going to put a couple of other videos on the screen, including the one that I solved this problem in a different using a different method, and I will see you in one of the other videos.